Let's do a few examples. R equals 4 plus 5 cosine theta. Immediately, I know it's a Limacon. I know it has polar axis symmetry, and it's positive, so the majority of the graph points to the right. I'm looking at A and B, modeling this on of A. R equals A plus B cosine theta. A is less than B. Oh, A is less than B? That means that I've got an inner loop. So I'm going to draw any old inner loop. I let those buns hang over, and I've got it going through the pole. Now, if I go up A and down A, I know these are going to be 4 away from the pole. If I go A plus B, I'm going to be 9 away from the pole here. And we said 4 away and 4 away. And here, I'm at A minus B absolute value, which will be 1 away. I don't care that my graph isn't exact. Notice I didn't do tick marks first. I've nailed down these points by telling you what they are. Now, if this angle here, I'm thinking in terms of r theta, which is not the same as xy. So I have to think directed distance, directed angle. I think this angle is 0. So let me plug in 0 for cosine. Cosine of 0 is 1 times 5 is 5 plus 4. So I do have that. That's r theta there. What if I did pi here? I'm going to have cosine of pi is negative 1 times 5 is negative 5 plus 4 is negative 1. So I have negative 1 comma pi. Wait, does that make sense? Of course it does. 1 pi would be over here, and then we reflect it over the pole, so that gives me that point. I think the angle here is pi over 2. Let me see. Cosine pi over 2 is 0 times 5 is 0 plus 4. Yes, so that makes sense. This is our pole, so the directed distance is going to be 0 there. And I think this is 3 pi over 2. Does that make sense? If I put 3 pi over 2 here, cosine 3 pi over 2 is 0, times 5 is 0, plus 4 is 4. So I can nail down those points pretty quickly. I don't have to guess. I can plug in for theta. Now, I didn't pick random points. I know it looks like this, so I took a good guess that that was a 0 angle. I know this can't be 0 because 0 gives me 9, so I thought, well, maybe I'm reflecting over the pole, which means I'd have to be at pi. If I'm up here, I guessed at pi over 2, and I guessed at 3 pi over 2, and I was right. That feels good, doesn't it? What if we had an example like this? I see it has 2 terms. Maramoja, it's gotta be a Limacon. What flavor of Limacon? A is equal to B. We're pulling that dent out, but it's not quite there. It gives us a cardioid shape. Now, it's cosine, but it's negative, so the majority of the graph is going to be pointing to the left. So all I have to do is draw a generic cardioid pointing to the left. I know it goes through the pole there. As far as away I'm going to be is 10 plus 10 is 20. I'm going to be up 10 here and down 10 here. Now, I think I've got those points correct. Let's see. I think the angle is pi. Cosine of pi is negative 1 times negative 10 is 10 plus 10 is 20. So I nailed that point. It wasn't just some random point I was pulling out of thin air. I think the angle here is pi over 2. Let's see. Cosine pi over 2 is 0 times negative 10 is 0 plus 10. Looks like I did nail that point. How about here? Well, it looks like that angle would be 3 pi over 2. Did I get it right? Let's see. Cosine 3 pi over 2 is 0 times negative 10 is 0 plus 10 is 10. Yes, and then it goes through anything with an r of 0. I don't care what the angle is here. As long as the r is 0, I'm going to get a point through the pole. Now, what would give that to me? Well, anything that gives me a cosine of 1. So if I put in a 0, if I put in a 0 for my angle, cosine of 0 is 1 times negative 10 is negative 10 plus 10. So that point happens to be 0, 0. That's r theta. That's not xy. R equals 5 plus 4 sine theta. 2 terms. Oh, I know it's a Limacon. Positive sine. Well, it's going to have theta equals pi over 2 symmetry. Positive, I know it's pointing up. Now comes a little bit of a tricky part. I have to compare A and B. A is bigger than B, so I know it's either a dimpled limacon, or if A is much bigger than B, I'm going to have a convex limacon. This divided by this is 5 over 4 goes 1.25, not qualifying for our convex limacon. So it must look something like this. Dimple, something like that. Now I'm going to go all the way up to 9. And this backside is 5 minus 4 absolute value is 1. And here I'm going to be over A, which happens to be 5, and over A, which happens to be 5. Notice I don't say negative 5 necessarily. Let's see. I think this angle is pi over 2. Sine of pi over 2 is 1 times 4 is 4 plus 5. I nailed it. So I'm pretty good at that right quick. If I put a 0 in, I get sine of 0 is 0. Remember your unit circle. Times 4 is 0 plus 5. So that's the case. That's r theta. Over here, I think this is pi. Sine of pi is 0 times 4 is 0 plus 5. I nailed it. Now, if this is pi over 2, maybe this one is 3 pi over 2. Sine of 3 pi over 2 is negative 1 times 4 is negative 4 plus 5 is 1. So these are pretty easy, right? Notice this is with the dimpled limacon, the pole is inside of my graph. Be careful of that. I've seen a lot of students draw some crazy stuff with this sort of floating above the polar axis. We have theta equals pi over 2 symmetry here, BTW. R equals 18 minus 9 sine theta. I know immediately, two terms must be a limacon. A is bigger than B, and not only is it bigger than B, it's much bigger than B. We've got that 2-to-1 ratio of A to B, so it qualifies as a convex limacon. It's a sine, so I know I have this theta equals pi over 2 symmetry. It's a negative sign, so I know it's pointing down, and I'm going to get this sort of egg shape pointing down. Notice this will be A plus B, so 9 and 18 will be 27 away from the pole. I'm 18 away on either side. Notice I'm not doing 18 and negative 18, although I could. And up here, I'm going to be 18 minus 9 is 9. Absolute value is 9. Let's see what those angles are. I think this angle is 0. Sine of 0 is 0 times 9 is 0. 18 minus 0. So I did nail that. How about this one? Pi. Sine of pi is 0. 18 minus 0 is 18. So I get those 2 points. Pi over 2. Sine pi over 2 is 1. So if I put a pi over 2 here, I get a 1. 18 minus 9 is 9. So this one is pi over 2. This one is probably 3 pi over 2. Let's see. Sine of 3 pi over 2 is negative 1 times 9 is, negative 1 times negative 9 is 9. 18 and 9 is 27. So you can see I can figure out what those points are pretty quickly. Notice also with a convex limacon, the pole is on the inside of our graph.